Well, thank you, JJ and Wendy. We can actually get started a little more quickly, so I can either sit down for 10 minutes or get started now, or perhaps talk more slowly, and I guess probably I will talk more slowly or say more. Okay, Electronic Research Administration, what's in it for me? Well, what I'd like to do is talk a little bit about the purpose, and it'll be sort of interwoven within the presentation. Give a little background to this. I like quotes. Those of you who know me and have heard me speak before, I always have quotes, and I have a few new quotes. I want to talk about what is ERA, why are we doing ERA, objectives and goals of ERA, and how is it being accomplished. Okay, let's talk about the basics. And by the basics, I mean, where did this originally develop? In the 1960s, there was an interview of a maintenance man in a NASA assembly gantry. And they said, what do you do around here? Now, he could have said, well, I sweep the floors. He could have said, I pick up the trash. He could have said, I polish the doorknobs. But he didn't say that. What he said was, I'm helping put a man on the moon. And that's what he was doing. He was part of the overall effort. And so when we talk about the NIH, it's just not to review grant applications. Yes, you're reviewing grant applications, but you're not just reviewing grant applications. You're not just funding research grants. You're not just conducting research if you're in the intramural. What the mission of the NIH is to uncover new knowledge that will lead to better health for the public, not only the United States, but the world in large. And ERA is really one of the methods by which this is being accomplished. There are lots of methods around, but ERA is one of those. Now, my quotes. I think there is a world market for about 5 computers, obviously said by a very perceptive individual. This was said a while ago. I don't know if anybody wants to guess, but clearly as somebody who didn't know very much about computers. Oh, wait. Thomas Watson, chairman of IBM back in 1943. Clearly, he couldn't predict the way things were going. And then there's somebody who said there's absolutely no reason for anybody to have a computer in their home. Clearly somebody who didn't know very much about computers. Well, president of Digital Equipment in 1977, not all that long ago, but certainly before the development of the personal computer. And then a classic phrase, 640K ought to be enough for anybody. Clearly, this person didn't know anything about computers. We're now in a system where if your computer doesn't come with 512 megabytes, it's not going to work very well. So this naive individual went on to found a small company, which nonetheless, back in '81, not all that long ago, is doing okay, I guess, nowadays. And make sure that we need computers that have even more and more RAM than they ever did before. Well, you didn't think I was done with the quotes, did you? Okay. This is also a good quote. You've probably heard of this, and everybody knows who said that. And that's Robert Zimmerman, who's also known as Bob Dylan. And think back. When I first got to the NIH, not all that long ago, in the extramural program in the late 70s, the height of technological accomplishment in our offices was an IBM Selectric typewriter, an electronic calculator. I think I had a fluorescent lamp on my desk. And the word processing capability was an IBM MagCard 2, which only one secretary in the office even knew how to use. And it took up the size of a small desk, and it was really just a magnetic card memory attached to a typewriter. And then, when I finally got an upgrade to an IBM Selectric with a self-correcting key, I was in hog heaven. I mean, I would do almost anything to avoid altering and changing a document. I would, argue with my boss, no, it's fine the way it is, because I knew if it had to be altered, it had to be completely retyped. Then we went to Alexitron. At that point, who cares? You can just change it, print it out quickly. Well, actually not so quickly, because the typewriters that were used were really typewriters, and they had to actually go through and print each page. We didn't have laser printers. But then I think about 84, 85, we got an IBM XT computer. Now, this was not something you easily got at that point. I was in the old Arthritis Institute, the NIAMDD at the time, and they were going to get one computer for the entire extramural program. There were 4 programmatic divisions. And we each, because we didn't know if it was going to be useful or not, and we each had to compete to get this one computer. And we must have put in justifications that were really pretty good because they ended up getting 4 IBM XTs, each with massive 20 megabyte hard disks and a 5¼ inch floppy. And they might even have 640K of RAM, who knows, but maybe they didn't have that much. And we figured out how to use them when it really wasn't for very much. We were just experimenting with them, trying to tap into bulletin boards. There was no internet at that time. And then gradually, we got Lexitrons. And the Lexitrons, we got more and more of those. But then, after everybody had a Lexitron, and they were all being used 8 hours a day, plus a common use one, we found that there was software for the computer which you could do word processing on, something called WordPerfect. But that wasn't the only one. There was WordPerfect, there was XyWrite, there was Professional Write, there were lots of things out there, and everybody was using something different. And so we ended up getting that, and then we replaced the Lexitrons with IBM XTs and then some ATs, and we had these dot matrix printers, and we had these electric typewriters that were connected to the computers. But then we finally got what was called a laser printer, and we got one of those to see if it worked. And then, of course, we got another one, and we attached it to all the computers that we had in the suite. And the people in my extramural program still remember the fact that I strung blue cables along the ceiling and the walls to connect all the computers with that. And I think I even have a picture. Unfortunately, I don't have it with me to do that. And then we got more laser printers, and it hasn't stopped yet. And, I mean, back then, we didn't have fax machines. How could you do without a fax machine now? Email, you use Wilbur for email, and nobody used it. You might log in once or twice a week, if that, maybe once a month to check and see if you had email, and usually didn't have any email. But things now have advanced to the point where we all have cellular phones, we all have Blackberries. Well, I mean, all have Blackberries. But there's cellular phones, there are Blackberries, there are Palm Pilots, there are Cliés, there are pagers. We can't get out of touch. And that also falls into line to the next one. A company's fundamental strength is its ability to adapt to change rather than predict it. Now, I'm not going to make you guess who this was. It was Jack Welch, who's former CEO of General Electric. And it really doesn't matter if you can't predict where you're going, but you're going to have to adapt to it. It's like the NIH. We couldn't have predicted back in the late 70s where we are today. We couldn't have predicted the budget. We couldn't have predicted the technology. We probably couldn't have predicted anything. But it's here, and we have to adapt to it. And ERA is part of that adaptation process. Now, I also have some rules, that you have to always have rules when you're adapting to change. Rule number 1, the basic. We have been and will continue to be in a state of transition for the foreseeable future. And if you think technological change is going to stop, you're wrong. It'll continue. There's lots of things coming down the pike that you haven't even believed would be possible and are going to be here soon. But there's a corollary to that rule, which I call rule number 2, which is transitions are hell. You always have to change. I mean, there are people I know who wish summary statements were still printed on pink paper. It ain't going to happen. In fact, you're probably not going to have any paper around eventually down the road. I mean, the summary statements, as they are now, are images. If you want it, you print it out on your laser printer. They're not going to be produced. I mean, there was an entire culture of the color of the summary statements. You know, the fellowships were on buff, or program projects were on something. There were green ones, there were pink ones, there were blue ones. And you just knew by looking at a stack of paper approximately how many RO1s were in there, how many fellowships, how many Ks, and so forth. And unfortunately, that's gone. It was a very colorful time. But, you know, pink paper didn't recycle at that point. So, okay, what is ERA? Now, when we were passing around and developing the poster for this, the original one didn't say Electronic Research Administration, what's in it for me? It said ERA, what's in it for me? And when I showed it around the Institute, the main question was, what's ERA? And the simple answer to ERA is, oh, well, yeah, if you're shopping, it's ERA, but that's not really what ERA is. So what really is ERA? Well, it's the infrastructure that basically will convert NIH from a paper organization to an electronic organization. So we can do all electronic transactions for receiving grant applications, for reviewing grant applications, for administering the awards to all the people out there that we have to work with. And it consists of two systems, the NIH Commons and Impact 2. Now, we're not going to talk about the Commons very much today, but the Commons is what enables communication with the people out in the community. It's our interface with them, just like the Commons in a university where everybody meets together. And it's the interface where everybody joins. Impact 2, on the other hand, is a system that's used by NIH staff. And we're going to talk about that today and talk about the new modules. There's lots of modules around in there. But why are we doing all this? It's a lot of work. It involves hundreds and hundreds of people. It involves tens of millions of dollars. It involves lots of time. It's been going on, it seems, forever. In fact, I remember sitting in the annex of the old Westwood building talking about the EGAD system. EGAD was electronic grant application development. And we were talking about how to get applications into the NIH in electronic form. Now, this was before the internet was around. And we were saying, well, we're going to have so many banks of modems because we're going to have all these people sending in their applications for some reason at the very last moment. So we're going to have X number of hundreds or thousands of modems and have the data stream. It wasn't even data streams. It was all the phone calls coming in. Well, things have changed a little. But each year at the NIH, we have about 46,000 applications. It's a lot of paper. We have over 3,200 review meetings being conducted. We have about 80 advisory council meetings underway. We have over 60,000 awards that we make of competing and non-competing types. We have 2,200 grantee institutions around the world, not just in the United States. We have over 100,000 applicants, not all of whom are successful, but they're applicants nonetheless. We have about 200 million pieces of paper. 200 million. It would fill this table. Well, maybe a little more than the table. Each day, there are over 3,500 users from the OD and from the institutes. And we have about 1.6 million transactions. And it's not stopping there. It's growing all the time, and it'll continue to grow. And the result of this is lots of paper. Now, you see GIPIA, and you say, huh, he forgot how to spell GIPRA. No, it's not GIPRA. GIPIA is something different. I don't want it to be confused with what's known as the Paperwork Reduction Act or GIPRA, the Government Performance and Results Act. GIPIA is the Government Paperwork Elimination Act, and it has a public law involved with it. And it basically says that all of the government, not just the NIH, has to become a paperless organization. We have to become a paperless organization in terms of our interaction with the public, in terms of doing electronic signatures, because if you're not getting in paper, there has to be some way to make sure that the applications and whatever paperwork you get in are valid, and those are electronic signatures. And you have to be able to conduct official business by 2003. That's the deadline given in the law. And whether we like it or not, 2003 is next year. And in fact, in July of 2003, applications in electronic form will begin to arrive at the NIH. We can't really predict the percentage of those applications. Certainly won't be 100%, certainly won't be 0. Could be 5, 10, 15%, but it's coming. At the moment, though, the paper application is the official record. Now, there are people who spend every waking day of their lives in the National Archives and Records Administration, NARA, dealing with electronic activities, not only paper and how do you store archival data, but how do you deal with the new electronic age that we're coming to. And I think that, and in fact, they are working on making a system so that the electronic application is the official application. Because don't forget, we won't be getting in paper, so we have to figure out how to store it. We have to figure out how to get rid of it when it doesn't have to be stored anymore. We have to figure out things like Freedom of Information Act. How do you redact an electronic application? Do you print it out, cut it out with a razor blade, Xerox it, and then turn it back into electronic form? It's an interesting task. How do you make sure that the media, that the electronic application or anything in electronic form is being stored on is readable? I would suspect that not very many people have 5 1/4-inch diskettes drive on their computers. If you have a 5 1/4-inch diskette, unless you have an old IBM XT at home that's working, you can't read it. And it's DOS anyway, it's not Windows, so it's even more difficult to do that. But one result of this is paper. And yeah, this is going to fit more than on the table. And this is just a small section of a CSR receipt area. And we get lots of paper in. We, in fact, are drowning in paper. It doesn't stop. And the applications come in on a receipt date, but it takes days, sometimes weeks for them to be processed, because you can only have so many processed a day. I think it's about 400 till you unwrap them, get them into the system, code them, do all the sorts of things that you need to do. Well, there's another result of that, and the result is that you get overload. Now, I don't know about you. Some days I feel like that, but some days I feel like that. And it's just the cost of doing business. You have to deal with all this stuff. And some days it seems like it's hard to deal with. But ERA, I would hope, would reduce this paper burden so the donkey can get back down on the ground again. Okay, so what are the objectives of ERA? Well, it's to convert all the paper that we have in the application process, the peer review process, the council review, post-award administration, and award administration into an electronic medium so that we can get the job done more efficiently. It's really pretty simple in concept. Now, in practical terms, getting it to work is a little more tricky. Okay? We also want to make sure that this process is integrated with all the business systems at the NIH and with the Commons. If the systems don't talk to each other, then it's not going to do any good. Anything that we add to ERA in terms of a new system has to talk to the existing systems that are already there. If that doesn't happen, it's not going to work. Okay? So the goals of ERA are to implement a user-driven, as Wendy Baldwin said, user-driven. This is coming from the community. And it has to be user-friendly. If something is hard to use, you're not going to be able to work on it, and you're not going to want to use it. It has to be reliable. It can't go down. It is our system. I actually had copies of the NIH Guide to Grants and Contracts from Volume 1, Number 2, which I started collecting when I was a postdoc. And I kept those for many years. I moved to Baltimore to the Aging Institute. I kept my copies. I moved down to Bethesda. I kept my copies. And it was taking up more and more shelf space. And then one day, miraculously, it became available on the internet. And I got rid of everything. Now, one can say a 10-year-old copy of the NIH Guide, you probably should have gotten rid of much sooner than that, and you're probably true, but I tend to be somewhat of a pack rat. But I don't keep any copies. They're all available on the internet. I used to keep copies of manual issuances just to have them ready to refer to. I don't do that anymore either. They're all available on the internet. But that is predicated on the internet being up all the time. It's predicated on the computers working all the time. So it has to be exquisitely reliable. It also has to be secure. Only the people who are supposed to get into a system should be able to get into the system. If people from the outside can hack into the system, then it's not a very good system. So there are passwords, and they're checking IP addresses to make sure that only the people who are supposed to get into something get into something. We also need to provide a computer architecture, which is getting to be a little arcane for talk about, but I want to mention it, so that everything can be changed quickly. Things are changing. Like I say, we're continuing to be in a state of transition. So if some new rule comes down, some new law gets passed, something has to be added, a new assurance perhaps, we have to be able to make sure that the system is capable of handling all those changes. You can't just create a system and have it static for all time. It's not going to work. So technology changes too. I mean, originally we were talking about having relatively modest computers. Well, the computers are more capable, and it requires more computer power to do this. And we also have as one of the goals to inform, educate, listen to, and respond to the user community. And that is, in fact, why we're having sessions like this. Because we're informing you, In fact, there's a representative from the help desk, the Impact 2 help desk out there. So if you have any specific questions about any of the modules, please feel free to stop in at the end of the registration desk and ask those questions. There's email access to questions as well on the internet and on the ERA website, and I'll give you the URL for that later. And so it is a user-driven system. We have to make sure there's interaction, because if, as I said before, it's not easy to use, nobody's going to use it, and it's the way we do business now. Now, what are the benefits of ERA? Well, we're going to be able to access information differently and in many more ways than we could have done previously. I remember a program director who no longer works for the NIH, retired many years ago, said, you know, it would be really great if we could just put down our program and be able to have the computer to print out all of the applications in our program. Now, this was an individual who he had given an XT to, and then I guess about 3 months later we took it out of his office because he had never turned it on. But he was frustrated because he didn't know how to use it, and the system couldn't do what you wanted it to do. If you wanted to do a data search in Impact 1, you had to really know query language. You had to be a techie to get into that. That's not the case anymore. You can go into the electronic counsel book, you can go into the QVR system, you can go into QuickView, any other number of modules, and get the information that you need. There are a variety of extension systems around that you can do that to, specific to certain institutes. And so we can get a lot more information than we could have gotten. In fact, we just could not have obtained that information in the same mix that we could have previously. Also, the Impact 2 databases have been designed so they can be used as a resource for all the institutes. And they can be used as a resource through those modules or through the extension systems. Institutes have created their own extension systems to do data analysis, to do reporting, and a variety of other things. And maybe some of that won't become necessary as we enhance what's happening in the various modules. And then sometimes the ERA project has adapted various institute systems for enterprise-wide use to be used by the entire NIH. And we're looking at some of those systems now that we're not even talking about those, but to do data analysis and a variety of other things. But if everything is compatible and everybody uses the same database, then we can do a lot more things than we could have done previously. So how does this all fit together? Well, there are certain building blocks around here. And it all fits together under the overall enterprise information integration. That means everything has to fit, everything has to talk together. The ERA, the Impact, and the Commons, you could say, is right in the middle. We have the clinical information systems using the clinical center to get patient medical information, but they have to be integrated into the overall system. You have the IT systems, our payroll system, our personnel system, all the systems that make sure we do our job and get paid to do our job, to make sure that we have the facilities available to do our job. And then we have the common services developed by CIT. We have PKI is for encryption of data. We have portals, sign-on. In many cases, all you have to do is sign on a single time to get access to a variety of systems. You don't have to sign on with passwords and names every time you get into it. And that can only be done when things are organized centrally. And then the connectivity. Everything has to be connected together. The NIH is a huge place. On any one day, there are probably 20-some thousand people on campus, and we probably have close to that many computers around. And they have to be connected to all the sites. They have to be connected not only here, but to the Rockledge complex, to the Frederick complex, to the Rocky Mountain complex, to every place, all the buildings we have. And they have to be connected seamlessly. I can send an email down to North Carolina, quite frankly, quicker than I can make a phone call. And that's important.